Nisham friends, today's big video is about power electronics lecture series. This video I shall discuss about power electronics converter analysis. So let us start this video. Okay, first of all, how to discuss the different types of converters. What is the meaning of converters? So what is the function of converter? Converter is nothing but a purpose means a device which is used to control and convert the electric power based on the requirements and applications. So accordingly, the converters can be classified as say, AC to DC converter. Then we can have DC to DC converters. Third is DC to AC converter, and then we can have AC to DC converters. And also we are having different types of converters, for example, resonant converters and electric drive converters. Okay, so let us discuss each and everything in short detail. Number one, this is just a short detail. Okay, you can refer further to the different books. So I'm just giving the brief idea about different types of converters so that it will save the time also. So number one is AC to DC converter. Now, what is AC to DC converter? First, see this. What is AC to DC converter? Means, as the name suggests, that it is also known as rectifier, which converts AC power to DC power. As you can see here, AC power is converted into DC power, right? So this is AC power, and this is your DC power. Okay. So at output, you are having average value of V naught and I naught, or these values are finite. This converter will convert the power to DC power. Okay. So this is one thing. Now next is DC to DC converter. Now these converters are basically converting the DC power into DC power. So in high power application, these are known as choppers, while in low power application, these are called SMPS, switched mode power supply, or you can say SMPs. Okay. Now next is DC to AC converter. What is DC to AC converter? These are known as inverters. So this converter will convert DC power to AC power, whose average value of V naught and A naught I naught are zero, because in case of AC, the average output average value of this waveform is zero. So at output, both voltage and frequency can be controlled in this case. Fourth one is AC to AC converter. Generally, these are known as AC voltage regulators. ACVR भी बोलते हैं इनको. Okay, so these are converting AC power into AC power. So these converters will convert the AC power, and these at the output side, voltage can be varied, but the frequency is fixed in this case. Now, in this category also we are having cyclo converter. Okay, now this at output side the frequency can be controlled. Hence, these are also referred to as frequency converters. Next type of converters are known as resonant converters. Okay, now these are two types. One is ZCS, means zero current switching, and another is working on the basis of zero voltage switching. So these are two types of converters, ZCS and ZBS, and these converters are based on soft switching techniques. Next, the electric drives. Okay, in which we are having different types of drives. One, you are having DC drives, and another is AC drives. So you can have different types of drives. Accordingly, the converters will be employed. So prime motto is energy conservation in this case. Now, before moving further, there is a concept of how to deal with AC and DC waveforms. So first, let me discuss this comparison of different AC and DC waveforms on the basis of Fourier analysis. I'm just using or quoting the expressions, so don't worry about these expressions. I will discuss this later, but time being, I'm just using this expression. For example, I'm talking about AC waveform right now. This is the ideal AC waveform. Now, in case of inverter, you are getting an AC waveform like this, which is a rectangular wave, you can say. So this is pi, this is 2 pi, so this is my waveform, and the Fourier series of this waveform can be expressed by xt is equal to sigma 1 n135 4x upon n pi sine omega into n into t. Okay, where xr square means this is nothing but the RMS value of this waveform, which is nothing but x1 square, x plus x square plus x5 square plus 1, means all odd harmonics would be there. Okay, now RMS value, the harmonic component xh would be equal to xr square plus x1 minus x1 square under root. So this is the expression for harmonic component, and you can calculate total harmonic distortion as under root xr square minus x1 square upon x1. This is the expression for THD. Now distortion factor can be calculated by taking the ratio of x1 and xr. Now a THD, which is THD, which is given in terms of the distortion factor, is given like this: THD is equal to root 1 upon df whole square minus 1. So these are certain expressions which are helpful for example, in case of ideal waveform for sinusoidal pure sine wave, this total harmonic distortion would be 0. Then this distortion factor would be equal to 1. So you can refer this for the ideal waveform. Now next is for DC waveform. As you can see here, ideal DC waveform is constant with respect to time, but in case of rectifiers, we are achieving the DC waveform, which is a pulsating DC, as you can see in this particular diagram. So in this case, xt would be expressed by the Fourier series like this: xt is equal to 2x by pi. This is average or DC component plus even values of n 4x upon pi 1 minus n square cos n omega t. So this is the Fourier series expansion for this particular waveform, which is pulsating DC. In this case, you are getting xr square is equal to xdc square plus x2 square plus x4 square up to so on. These are the even values. Okay, so these are the RMS values of different harmonics. You can calculate the RMS value, the ripple component. In case of ripple component, we are calculating VH, which is nothing but under root v square minus vd square. So you can calculate the ripple factor like this: RF is equal to VR square minus vd square under root and divided by DC. So this is ripple factor. Accordingly, you can calculate the form factor also. The form factor is nothing but VR upon VDC. And finally, the ripple factor can be expressed in terms of form factor square minus 1 root. So these are certain expressions which are very helpful while we are analyzing different types of converters in the coming lectures. Now, first one is the AC to DC converter, because in this particular lecture we are emphasizing on AC to DC converter, which means rectifiers we are going to discuss. So rectifier circuit will convert AC power to DC power whose average value of output voltage and current are finite. तो यहाँ पर एक चीज ध्यान रखने की है. Next is the different types of application. What are different applications of rectifiers? So I'm just summarizing the application like this. They are useful for battery charging circuits, or you can use this rectifier into speed control DC motor or electric traction HVDC transmission circuit, renewable energy system. So these are certain areas where we can employ the DC, this AC to DC rectifiers. Now, as far as the rectifiers are concerned, there are different types of rectifiers. Means the classification of rectifiers is as follows. Number one is uncontrolled rectifier, then fully controlled, and then finally half controlled rectifier. So let us discuss one by one. Number one, I am discussing uncontrolled rectifier. So what is the meaning of uncontrolled rectifier? Means in this case, average output voltage cannot be controlled. Okay, and you can say it depends on the source voltage. So these circuits are designed with diodes only. Next thing is, based on the source voltage, they can be classified as either single phase uncontrolled rectifier, in which we are having half wave or full wave. And in full wave, there are two categories. One is center type and there is bridge configuration. Then another category is three phase uncontrolled rectifier, which is again of two types, half wave and full wave, which is again bridge configuration. Next is fully controlled rectifier. Fully controlled rectifiers are similarly categorized as, I just told you that average output voltage can be controlled in full range, that is minus V0 to V0 to plus V0, and it depends on Vs and alpha. What is alpha? Alpha is the firing angle that I shall discuss later on, and these circuits are designed with the help of SCRs, silicon controlled rectifiers. Okay. Next is, based on the source voltage, they can be classified either single phase controlled rectifier or three phase controlled rectifier. As you can see here, this single phase, there are two categories, half wave and full wave with center type and bridge. And similarly, in three phase, there are two categories, half wave and full wave with bridge configuration. Now, third one is called half controlled rectifiers. Now, half controlled rectifiers are the combination of the full wave, and means average output voltage can be controlled in half range, means 0 to plus V0, and it depends on Vs and alpha. So they are also referred to as semi-converters. They are also known as semi-converters. So these circuits are designed with both SCRs and diodes. Both SCRs and diodes are employed in these cases. Okay. So based on the source voltage, they are classified as single phase or three phase, both types of bridge configuration, as we have discussed right now. Okay. Now, some other points which are to be remembered, means the rectifier circuits can also refer as a number of pulses in the output voltage when source voltage completes one cycle. Okay. Then another important point is the ripple frequency of output voltage is f0, which is equal to n into fi, means input frequency होगा उसका n times होगा, जितनी pulse होगी उतने times आपकी output frequency होगी, where n is the number of pulse in V0 for one cycle. And another important point is the rectifier which contains both 3 and 6 pulses is three phase semi converter. So I will discuss each and every point in detail with all the configurations. Okay. Now there are certain configurations which we must analyze with the help of certain assumptions. So there are certain assumptions which we should take. Number one, Vs is pure sinusoidal. While we are analyzing the rectifier circuit, there must be a constant that the Vs is supposed to be pure sinusoidal. Then next point is devices are assumed to be ideal and the transition times are neglected. So keeping all these things, we shall discuss the different configuration in the coming lecture. So that's it for today. In the next coming lectures, I shall discuss the uncontrolled rectifiers. Okay. So till then, goodbye and Jai Shri Ram.